Okay, so this next short video is going over how browsers fetch websites, because as front-end developers, we are, of course, um, creating websites, well, the front end of websites at least. And when we obviously create the core of the front end of the application, so the HTML, the JavaScript, the CSS, that information then needs to be stored on a server somewhere in the world, hopefully through a CDN close to our end users. And then when their browser goes to, for example, www.google.com, how is that application, so the HTML, the CSS, the JavaScript, and any images and any other additional information, how is that information then going to get from the server on which it resides to the browser for the browser to then render the page? So that really is to do with kind of how browsers are fetching websites, how they're fetching the files that live on the server somewhere in the world, to then use those files to render the application on the screen. So I've created a cute little mnemonic just to help me, and hopefully someone else finds it useful, to remember just the kind of the steps that that is gone through in order to basically fetch the data. And this is done within the transport layer of the kind of network stack, because obviously it's the transport layer that is kind of responsible for the transportation of the data over the network. So it's on this layer that that HTTP is being utilized in order to actually make those requests to the server. We'll get into that a little bit later. So we're on the transport layer of which is TCP in this case, because we're using a web browser. So they most commonly use TCP, transmission control protocol, in order to transport data across the network to different devices. So we're on the browser. Well, the browser, we've typed into the browser www.google.com. What happens next? So I've created this analogy. Downstairs, cats sleep. So downstairs, cats sleep, giving granny's company are. That's the best I could come up with, which stands for DNS, the socket, connect to IP address, send HTTP request, get data, get additional data, close connection, and then show web page. That should not be bolded. It should just be the W. So first of all, the network doesn't understand what Google.com is, where Google.com servers are. That's not how computers speak to each other. That's not how the network works. The network uses IP addresses, which is Internet Protocol addresses, in order to know where different computers are, in order to access their resources, and also to send resources to computers. So IP addresses are completely unique. They're either static or dynamic. You usually have a static IP address for a server, and clients can be dynamic, as they can change without much kind of disadvantages that come along with it. So the so DNS, which is the domain name system, will be utilized by TCP to look up the IP address of google.com. So it will basically take google.com as an input, and then as the output, it will give the IP address, which will either be in IPv4 version or IPv6 version. I'm not really sure. But then it will, give back the IP address. So now we know the address of the computer, i.e. the server in this situation, that the Google server that we need to connect to resides on the internet. So now we can go to the next stage, which is to open a socket. So the socket is basically an endpoint. I'm still figuring out this terminology. But to my understanding, a socket is just basically an endpoint for sending and receiving data. So it opens a socket so that data can be sent and received. Then we go to the next step, which is to actually, through that socket, connect to the IP address on a specific port. So specific ports are associated with specific protocols. So for web developers, the most important ports for us to know are the ports used for HTTP, because it's HTTP requests that we are sending via the network, via the internet, to access resources and to send resources. So HTTP is on port 80 always, and HTTPS is on port 443, I believe, always. Those never change. And so you don't usually see these in URLs, but actually at the end of toward the end of the URL, you would see kind of colon 443 or colon 80. It appears in most URLs, but it is on there. And I'll get to that in a later video, because that just shows you basically which application on this computer am I trying to have access to. So you can't just send data to a computer or request data from a computer. You have to also provide a port on that computer, which is basically like a pigeonhole in that computer that holds that specific type of data that you want. And in this case, we're sending and receiving HTTP, and so all HTTP communication goes through port 80, and HTTPS goes through port 443, to my understanding. And so once we have connected, so the browser's connected to the IP address through the port, obviously still using TCP, then we can go to the next stage, which is to send the HTTP request over the connection. So we're connected to the IP address, we can now send the HTTP request over the connection. And of course, because we're using TCP, we'll need to have of course, done the three-way handshake. So now we've sent the HTTP, we've done the three-way handshake, we've synced with the server has acknowledged the sync and synced with us, and we've acknowledged the acknowledgement, and then we have created the end-to-end connection, and we can start sending data. So we send the HTTP request, the GET request for the HTML, and we get the data back, which is the next stage. And then, preferably within the same connection, for example, if we're using multiplexing, which I believe is on HTTP2, but on obviously HTTP1, it won't be within the same connection. But then we get additional data. So that's the CSS, the JavaScript, the images, etc. And then we go to the next point, which is to close the connection, and then we show the web page. So that's kind of how how browsers fetch websites, in my understanding. Pretty straightforward, and yeah, quite interesting also.